So, hello Sir Badana, I'm here to discuss the thermodynamics 2 problem. So, draw the TS diagram of pure substance level and identify the point. Specify the condition subcooled liquid, saturated liquid, with vapor, and etc. And determine the properties P pressure, T temperature, U internal energy, V volume, H enthalpy, S entropy of water for the following conditions. So, here are my TS diagram. So the temperature and entropy diagram. So here is the saturated line. Here this compressed liquid. So here is the saturated liquid. In the middle, in the top is the critical point, and here in the broken line in the middle, the wet vapor. The saturated vapor here, the constant pressure line in the broken line going to top, and this line, the broken line, is called the constant temperature line. Here is the superheated vapor on the right side, the line in the right side, saturated vapor line. So the given problems, so pressure is equals to 2 megapascal absolute, and the X or quality is equals to 90%. B, temperature at 200 degrees Celsius, and the X or quality is equals to 80%. C, pressure is equals to 0.535 megapascal absolute at a temperature of 300 degrees Celsius. D is equals to D, pressure is equals to 5 megapascal absolute and the temperature at 200 degrees Celsius. So to solve, here's the solution for A. Given the pressure 2 megapascal absolute and the quality X is 90% or 0.9, and based on the steam table, the temp here at 5 bar or 0.5 megapascal, here are the givens. So Vf is equals to 0.0117675 cubic meter per kilogram, is equals to 0.0998 cubic meter per kilogram. The internal energy of the saturated liquid is equals to 906.15 kilojoules per kilogram. The internal energy of the saturated vapor 2599.1 kilojoules per kilogram. The enthalpy of the saturated liquid 908.50 kilojoules per kilogram. The enthalpy of the saturated vapor equals to 2798.3 kilojoules per kilogram. The HFG is equals to 1889.8 kilojoules per kilogram. The entropy of the saturated liquid is equals to 2.4468 kilojoules per kilogram. So here, solving for internal energy, the internal energy of the saturated liquid plus the quality parenthesis internal energy of the saturated vapor minus internal energy of the saturated liquid. So substitute the given values. 906.15 kilojoules per kilogram plus 0.9 times parenthesis 2599.1 kilojoules per kilogram minus 906.15 kilojoules per kilogram. So the internal energy is equals to 2429.805 kilojoules per kilogram. So here, solving for the volume. So volume of the saturated liquid plus the X or quality parenthesis the volume of the saturated vapor minus the volume of the saturated liquid, parenthesis. So substitute the given values: 0.00117675 cubic meter per kilogram plus 0.9, parenthesis, 0.099585 minus 0.001763. So the volume, so we will have the volume of 0.0897447175 cubic meter per kilogram. So solving for the enthalpy, H is equals to enthalpy of the saturated liquid plus the X, parenthesis, HFG. So substitute the given formula, given values: 908.50 kilojoules per kilogram plus 0.9, parenthesis, 1889.8 kilojoules per kilogram. So we come up with a enthalpy of 2609.32 kilojoules per kilogram. So solving for the entropy, S is equals to entropy of the saturated liquid plus the quality, parenthesis, the SFG, is equals to 2.4468 kilojoules per kilogram plus 0.9, parenthesis, 3.8923 kilojoules per kilogram. And so we came up with the answer of the entropy is equals to 5.94987 kilojoules per kilogram. So the B, so we have here the given is the temperature at 200 degrees Celsius, and the quality or X is equals to 80% or 0.8. So we have here the table. So we have to find the in table 1, 200 degrees Celsius temperature. So here 200 degrees Celsius. So the given, so as the given values. So based on the steam tables, these are the values. So solving for the volume, so volume of saturated liquid plus the quality, parenthesis, volume of the saturated vapor minus volume of the saturated liquid, parenthesis. So substitute the given values: 1.1565 plus 0.8 the quality. So parenthesis times 127.36 minus 1.1565. So we came up with a volume of 102, 1,102,1193 cubic meter per kilogram. So solving for the internal energy, so internal energy of saturated liquid plus the quality times, parenthesis, U sub Fg is equals to 850.65 plus 0.8, parenthesis, 1744.7. So we came up with the internal energy of 2246.41 kilojoules per kilogram. So solving for the enthalpy, H is equals to enthalpy of the saturated liquid plus the X, parenthesis, the H sub Fg. So substitute the given values: 852.45 kilojoules per kilogram plus the 0.8, parenthesis, 1940.7. So we came up with a enthalpy of 2405.01 kilojoules per kilogram. So the last, solving for the entropy, S equals to entropy of the saturated liquid plus the X quality, parenthesis, entropy of the saturated vapor minus the entropy of the saturated liquid, parenthesis. So substitute the given values, 2.3309 plus 0.8, parenthesis, 4.1014. So we came up with the entropy of 5.61202 kilojoules per kilogram. So the C, so pressure is equals to 0.535 megapascal absolute, and that at the temperature of 300 degrees Celsius. So based on the steam table, in the table number 3, the vapor, so based on the steam table here, there's no 0.53, so we need to do interpolation in point at a given 0.52 pressure and 0.54 in the between of 0.53. So here are the given values. 0.52 at 300 degrees Celsius, volume is equals to 502.2 cubic meter per kilogram. So the internal energy 2802.6. The enthalpy of 3063.7. The entropy of 7.4411. So in 0.54 megapascal at 300 degrees Celsius, the volume is equals to 483.4. The internal energy is 2802.2. The enthalpy of 3063.2. The entropy of 7.4230. So solving for the volume, so 0.535 minus 0.52 over 0.54 minus 0.52 equals x minus 502.2 over 483.4 minus 502.2. So we came up with a volume of 488.1 liters per kilogram, or 0.488 cubic meters per kilogram. Here is the conversion for 4.881 liters per kilogram. So in every 1 liters per kilogram, there is 1000 cubic meter per kilogram. So solving for the internal energy, 0.535 minus 0.52 over 0.54 minus 0.52. The equality, the x minus 2802.6 over 2802.2 minus 2802.6. So we come up with the internal energy of 2802.3 kilojoules per kilogram. So solving for the H, or enthalpy, 0.535 minus 0.52 over 0.54 minus 0.52 equals the x minus 3603.7 over 3603.2 minus 3663.7. So we came up with the enthalpy of 3063.325 kilojoules per kilogram. So solving for the entropy, 0.535 minus 0.52 over 0.54 minus 0.52 equals the x minus 7.4411 over 7.4230 minus 7411. So we came up with the entropy of 7.4276 kilojoules per kilogram. So D, so at 5 pressure at 5 megapascal absolute at 200 degrees Celsius. To the given is 200 degrees Celsius. So we will search for the 200 degrees Celsius at the table 4, the liquid. Here at 5 megapascal. So here at 200 degrees Celsius. So based on the steam table, they are good. Here are the given. So the volume is equals to 1.1530 cubic meter per kilogram. So and the internal energy of 848.1 kilojoules per kilogram. And the enthalpy is equals to 853.9 kilojoules per kilogram, and the entropy is equals to 2.3255 kilojoules per kilogram. So the problem number 2, an engine is required to produce 4,500 kilogram of dry steam per hour. The quality of the steam in it is 90%. What must be the weight of the wet steam in kilogram per hour? So the given values, the mass of the steam is equals to 4,500 kilogram per hour. So the x, or the quality, is equals to 90% or 0.9. So here the solution, x equals to mass of the steam over total mass. So substitute the given values, 0.9 is equals to 4,000, the mass 4,500 kilogram per hour over the total mass. So the total mass would be 5,000 kilogram per hour. So problem number 3, the pressure cooker contains 1.5 kilogram of the saturated steam at 5 bar. Find the quantity of heat kilojoules which must be rejected so as to reduce the quality of to 60%. Dry mass of steam is equals to 1.5 kilogram. So the given values, pressure is equals to at 5 bar. So the initial quality, or x, is equals to 1, x sub 2, or the quality 2, is equals to the final quality is equals to 0.6. The temperature is 1.1 at 5 bar from the steam table. The temperature is equals to 151.8 degrees Celsius. The H sub Fg is equals to 2108.0 kilojoules per kilogram. The enthalpy of saturated liquid is equals to 640.1 kilojoules per kilogram. The volume of saturated vapor is equals to 0.375 cubic meter per kilogram. So solving for the volume. So initial volume is equals to final volume. So final volume is equals to volume in flat condition. So 0.56525 is equals to 1.5 parenthesis 1 minus x sub 2 the volume of the saturated liquid at final plus the x sub 2 times the volume of saturated vapor at final. So volume of the saturated vapor is equals to 0.5625 over 1.5 times 0.6. So the volume would be 0.625 cubic meter per kilogram. So we will get the volume. So volume is equals to mass times initial volume. So mass times the volume of the saturated vapor. So substitute the given values. So volume is equals to 1.5 cubic meter per kilogram and the mass 1.5 kilogram times 0.335 cubic meter per kilogram is equals to cancel a kilogram. So the mass will be 0.5625 cubic meter. So solving for the internal energy at initial point. So internal energy initial is equals to enthalpy initial minus initial pressure times initial volume. So enthalpy of the saturated liquid plus enthalpy sub Fg minus pressure P sub 1 or pressure, initial pressure, and initial volume of saturated vapor parenthesis volume 1 is equals to initial volume is equals to volume of the saturated vapor sub 1. So substitute the given values 640.1 plus 2107.4 minus 5 times 10 raised to the power of 5 times 0.375 raised times 10 raised to the power of negative 3. So 2747 minus 5.5 minus 187.5 is equals to 2560 kilojoules per kilogram. From the steam table at 0.625 cubic meter per kilogram at the final pressure of 2.9 bar, temperature of 132.4 degrees Celsius, and enthalpy of 556.5 kilojoules per kilogram. The H sub Fg is equals to 2166.6 kilojoules per kilogram. So the internal energy, solving for the internal energy at the final point. So internal energy is equals to sub 2 is equals to H sub 2 minus P sub 2 V sub 2 times V sub 2. So enthalpy of the saturated liquid plus the quality H sub Fg parenthesis minus P sub 2 times the volume of the saturated vapor. So the final volume is equals to X times volume of saturated vapor parenthesis. So substitute the given values 556.5 plus 0.6 times 2166.6 minus 2.9 times 10 raised to 0.5 times 0.6 times 0.625 times 10 raised to the power of negative 3. So equals 1856.46 minus 108.75. So we are given with the internal energy of 1747.71 kilojoules per kilogram. So the heat transferred at the constant volume per kilogram, internal energy, final internal energy minus initial internal energy is equals to 1747.71 minus 2560 equals to negative 812.29 kilojoules per kilogram. So the total heat transferred is equals to negative 802.29 times 1.5. So the answer would be negative 1218.43 kilojoules. So problem number 4. Steam enters at the engine at a pressure of 10 bar absolute and 400 degrees Celsius. It is exhausted at 0.2 bar. The steam at the exhaust is 0.9 dry. Find the change in enthalpy and the change in entropy. So given at the 10 bar, given values, pressure is equals to, initial pressure is equals to 10 bar. The final pressure is equals to 0.2 bar. The temperature at 400 degrees Celsius, the final quality of steam is equals to 0.9. Based on the steam table at 10 bar, where at 400 degrees Celsius on table 3, the enthalpy is equals to 3263.9 kilojoules per kilogram. The entropy is equals to 7.465 kilojoules per kilogram. So enthalpy is equals to enthalpy of the superheated, and entropy is equals to entropy of the superheated at, and also at that 0.2 bar from the steam table. Here are the given values. So we need to solve for the entropy and the enthalpy. So H sub 2 is equals, final enthalpy is equals to enthalpy of the saturated liquid plus the X, final quality is parenthesis H sub Fg is equals to 251.5 plus 0.9 parenthesis 2358.4. So we came up with the enthalpy of 2374 kilojoules per kilogram. So the entropy, final entropy, so equals to entropy of the saturated liquid plus the X S sub Fg is equals to 0. Substitute the given values, 0.8321 plus 0.9 parenthesis 7,900 79,094 minus 0.8321 7.9094 minus 0.8321 equals 7.2016 kilojoules per kilogram. So the drop in enthalpy or change of enthalpy initial minus change enthalpy final, so equals the values 3263.9 kilojoules per kilogram minus 2374 is equals to 889.9, so kilojoules per kilogram. So therefore the enthalpy has dropped. So in the change of entropy, find initial entropy minus final entropy. So 7.465 minus 7.216 is equals to 0.2634 kilojoules per kilogram. So the entropy has decreased. So okay, sir, that's all.